Welcome to The Explainer. Today, we're getting into the science behind one of sci-fi's most incredible creations. You know what I'm talking about, the giant humanoid robot, the mobile suit. All right, let's just jump right in with the big question, the one that really gets us all excited, right? Could we actually build something like this, an 18-meter-tall mobile suit, with today's technology? To get to the bottom of that, we're gonna have to separate the real science fact from the, let's be honest, amazing science fiction. We'll look at the huge hurdles that stand in our way, but also the totally brilliant solutions the story comes up with that make this whole idea just so cool.
Okay, so let's get into it, and we're gonna start with the most basic problems. Like, forget the fancy weapons for a second. Let's just talk about the sheer size, the stance, and the power needed for one of these things.
So here's the thing. When you look at it from a pure engineering perspective, a giant two-legged robot is, well, it's pretty much the opposite of what you want for a real-world war machine. Think about it. A mobile suit has this super high center of gravity, which makes it inherently unstable. It's a massive, easy-to-hit target. A tank, on the other hand, it's built low to the ground for a reason. It's stable, efficient, and way harder to get a lock on. And that brings us to the next massive problem, power. I mean, the energy you'd need to move an 80-ton machine around, let alone with the kind of agility you see in the shows, it's just astronomical. Our absolute best cutting-edge battery technology today, it would be toast. We're talking maybe a few minutes of operational time. That's it. All right, so let's move on to the next big challenge. Let's talk about the actual anatomy of one of these machines. The materials, the movement, the real nuts and bolts of how it all works. Okay, this little scorecard here really lays it all out, doesn't it? It shows us where reality is actually starting to catch up to fiction, and where we are still miles away. So for materials, we're getting there. We've got advanced stuff like carbon fiber reinforced polymers, titanium alloys, super strong, super light. But then you get to the actuators. You know, the artificial muscles that have to move tons of weight. Yeah, we've got nothing even close to powerful enough for that. And don't even get me started on shock absorption. Can you imagine an 80-ton machine landing after a jump? The physics of that are just a nightmare. Okay, so even if we could somehow build the machine, we run into maybe the biggest hurdle of all, the human factor. I mean, how on earth could a single person actually pilot this monster? And what's wild is, we actually have some tech today that points toward an answer. You can imagine a cockpit with like a super advanced VR setup, or maybe a full-body motion capture rig where the robot just mimics the pilot's movements in real time. We're even starting to see early brain-computer interfaces. The ideas are there. But even if you solve all that, even if you create the perfect control system, all you've done is uncover an even bigger, much more dangerous problem. And this one isn't about the machine. It's about the squishy human inside. Yeah, think about it. All those awesome, agile maneuvers that make a mobile suit so cool in a fight, the high-speed dodges, the instant changes in direction, those massive booster jumps, they regenerate absolutely crushing G-forces. A human pilot's body just can't take that. You'd be talking about passing out instantly, or worse. So after all of that, all these seemingly impossible problems, this is where the whole thing gets really interesting. This is where the science fiction pulls out its trump card, a single brilliant piece of world building that neatly solves almost everything. It's the Minkowski particle fix. So what is the Minkowski particle? Well, it's this fictional elementary particle that, when you spread it across a battlefield, just completely jams up all electromagnetic waves. That means no radio, no radar, no remote guidance, nothing. And this is the absolute genius of it. You see, this one little particle sets off a chain reaction. First, you scatter the particles. Suddenly, all your high-tech stuff, your radar, your GPS, your guided missiles, it all fails. Long-range electronic warfare becomes totally impossible. So what happens? Combat has to revert to close-range, visual-based fighting. And in that kind of world, suddenly, a giant, heavily armored, visually guided humanoid weapon isn't just a cool idea. It's a military necessity. So, okay, we've established that the 18-meter-tall mobile suit is probably going to stay in the realm of sci-fi for a while. But that doesn't mean the story ends there. The ideas behind it, they're having a very real impact on the technology we're building today.
You can literally see the echoes of these sci-fi concepts all over the place. We've got powered exoskeletons that give workers superhuman strength. We're developing AI co-pilots to help manage complex systems in fighter jets. The incredible balancing tech in those walking robots you've seen online. That's a huge step. And even the idea of support weapons, well, we have AI-powered drones filling that role right now. Fiction is absolutely inspiring reality.
And this really breaks it down nicely. The scale is different, for sure. We're not building giant bipedal robots, we're building smaller, specialized drones. We don't have miniature fusing reactors, but we're pushing the limits of battery tech. But look at the bottom two. AI-assisted piloting? That's happening. And the fictional physics of jamming everything? Well, that's just a sci-fi version of the very real electronic warfare and stealth technology we use today. The core ideas are running on parallel tracks. So in the end, the big takeaway here isn't just about what's possible or impossible right now. It's about how imagining something truly impossible, like a giant robot, and then thinking through all the problems, that process is what pushes us to invent the real technology of tomorrow. It makes you wonder, right? As our robotics and our AI get more and more advanced, what impossible sci-fi idea is going to be the next one to spark a real-world breakthrough?